171 Business Analytics. Thanks, Ishan. Hopefully online students can hear me all right as well. We'll start today with a promo, a brief intro to past sessions. We have Hannah here who will be leading the sessions. She'll give you an intro as to what to expect, the additional support through PASS, and then we'll continue with our lecture. Hannah, over to you.
Thank you. Yes, hi everyone. My name's Hannah and I'm your PASS leader for this trimester. Just a little bit about PASS. Pretty much it's peer-assisted study sessions. So I did business analytics in T1 last year and really enjoyed it. It was a really good foundation for all the other units I've been building on. And pretty much it's kind of like a bit more of a relaxed seminar. We can come with any questions, any queries, and if you're a bit stressed about the pace of the unit, we can really break it down. I have a few questions, examples. We work on like tips and tricks, help each other with any like big questions or struggling with any assignments. I can also ask the lecturer for you if you're a bit nervous, which is kind of nice. Everyone who came last trimester seemed to have really good feedback, which was really good. Everyone seemed really confident by the end, the progress that people made. Some people had never used Excel before. That was me when I did it last year. So there's a really big rapid improvement, which is really nice. They'll be running Monday, 3 p.m. So if you're feeling fired up after the lecture, you can jump right on, or 7 p.m. as well. They're just on Zoom, run for 50 minutes, super relaxed, jump on, jump off. Come every week or whenever you feel you have a question, or if you want to make some friends in the unit as well, everyone kind of just chats. And it's really nice. This is how you find them, just on the unit site. That's pretty much it. I hope I can see you guys there. Hopefully it'll be really fun. We also have a Facebook page as well, which I'll just post like questions, tips, tricks. You can communicate with other people in the unit as well if you're struggling. So feel free to join that as well. The little code will be up on the lecture slides for the week as well. Perfect. Thank you, and hopefully I'll get to know you guys soon. Thank you.
Thank you very much. Appreciate
it,
Hannah. Thank you. Yes, why not? 2 claps, but that's okay. Thanks again, Hannah. See you. All right, so let's get to it. In week 1, we discussed a few relevant concepts to business analytics. We talked about what business analytics is, the importance of data. We talked about the 3 components, types, techniques, pillars, whatever you want to call them, of business analytics. That's descriptive, predictive, and prescriptive. Today's class is going to focus most entirely on descriptive analytics, one form of descriptive analytics, univariate analysis. And next week's class is going to be about bivariate analysis. So Uni 1 means the focus is going to be on a single variable, and our analysis is going to focus on that one variable. Bivariate, which we're going to cover next week, is going to look at 2, obviously by 2. So 2 variables and how they relate to one another. That's what we'll cover next week. Now, why are we doing this? Why do we care about descriptive analytics anyway? So when we are presented with data, unless you're a savant, it is quite difficult to make sense of it just by looking at the numbers or the text or whatever it is that data set contains. Our number one objective, the first task of a business analyst is try and summarize that data to come up with a description of what it could mean. And that's how we build on and perform further more advanced analytics. So the first task would be to essentially just come up with a summary. If we're interested in a single variable, that's univariate analysis for us. There's different ways that we can perform univariate analysis. There are certain statistical measures or numbers that you can present as a summary. You're probably all familiar with some of these, for instance, the average. So if you've got a range of values, one of the ways that you can summarize that range of values is to add them up, divide them by the total, and calculate the mean, arithmetic mean or average, and present that as one form of summary. There are other ways as well. That's what we'll focus on in today's class. I will try to refer to our Vicversity case. This is the case I mentioned we will be coming back to throughout the trimester in our classes. It's a fictitious university data set, university-based data set. It contains information about students and the scores they've received in multiple core units. It also provides some details, personal details like characteristics, like whether they're international students or domestic ones. International is indicated by an I under column C or origin, and domestic is indicated by an L, local, under column C or origin. So we will keep referring to this throughout today's class and also in future classes that we'll have together. Today's focus is going to be on Core 4. Core 4 is one of the units that all the students in this data set have gone through, have enrolled in, and now have a score in. There are various scores, as you can see. The first person in this data set has scored 70, the second one has scored 63, et cetera, et cetera. Now, if you look at that one individual variable, Core 4, there's a lot of values there. And it's pretty hard for people to look at those values and try to action something off of it or make a decision. So if you're someone higher up in the university and you're thinking, how can I make sense of the Core 4 values that I see? Are students receiving enough support in this unit to do well? Do we need to provide additional support? Are the assessment tasks so easy that everyone's getting an HD, for instance? Everyone's getting really, really high marks. Do we need to make it a little bit more challenging? The way they can make those kinds of decisions is if they can actually understand those values. And just by looking at those values, 70, 63, 83, 75, it is quite challenging to make those kinds of decisions. So today we're going to discuss what we can do to make this more understandable. There are three types of measures or numeric ways that we're going to look at a number-based variable like Core 4. There's central tendency measures, there's dispersion measures, and there's measures of shape. These are the three that we're going to focus on today, and together talk about how we can go about measuring these for Core 4. We'll start with central tendency measures. Like I said, one of the most famous ones is mean or average. Pretty much everyone here should hopefully know how to calculate the mean of a range of values. The other one is mode. Can anyone help me out, whether online or over here? What do you know about mode? How do we go about calculating mode? Thank you.
It's just the item with the largest number of the data set, like for that specific item. So if you said like how many people, like if you have a data set of like 10 to 100 like of people, and you just pick like, if the most common one's 50, then 50 is the mode.
Most common one. Very good. Thank you very much. So most common or most frequently occurring value in a range of values is considered the mode. Now this can be, looking back at last week, we have two high-level types of data. It's either number-based, quantitative, or it's text-based, qualitative. With number-based values, you can find the mode by simply looking at the data and figuring out which value. If I look at core 4 values and find the score that most people have received, that will be the mode. So let's say 63 or whatever the value is. But you can also do this for categorical or text-based variables as well. You have a basket of fruit. There's 5 apples, 2 oranges, and 1 pear in that basket. The mode will be apple, right? Because that's the one with the most frequency in that basket. What about the next one, median? So we know what mode is, we know what mean is. Median, if you sort a number-based variable's values from smallest to largest and find the middle value, that is your median. Half of the values in that variable are above this median and half of them are below this median. Does that make sense? Yeah? Can we calculate the median value for a categorical variable? No? Unless the other one. Ordinal. Very good, yes. But we're not going to look into that in this unit. Okay, so we know mean, we know mode, and we know median. Those are the 3 main points of measures of central tendency. These, all 3 of them look at the center of a variable's values. It's not enough just to look at mean, mode, and median. The main reason that we are interested in other statistical measures to look at and summarize a variable is because it's not enough just to look at the center. I'll give you an example. Imagine that with the core 4 values, so core 4 actually refers to business analytics, the unit of business analytics. Imagine that every student in trimester 1 who enrolled in business analytics in core 4 got 50 out of 100, everyone, except for 2 people. One person got 0, the other person got 100, which is the highest mark. Everybody else got 50. The average or the mean of all core 4 scores will be 50, right? If you add all the scores and divide them by the total value, the average or the mean will be 50. Now imagine that 50% of this is scenario 2, 50% of everyone enrolled in MIS 171 in trimester 1 received 0, and 50% of them received 100. What is the mean going to look like? 50, again 50. But these 2 are very, very different sets of values. In one, as a unit, you're not doing so great because half the people in your unit have failed with a 0 and half of them are receiving HDs. So you need to adjust the way that you're delivering the unit. This is a very different cohort and a very different result for the unit compared to the scenario where everyone's received a 50 except for 2. So just looking at mean, mode, and median is not enough. That's why we look at other measures. One such set of measures is the are the measures of dispersion or spread or variability. I'll come back to quartiles in a second. So measures of variability or dispersion. There's quite a few of them. There's standard deviation, there's variance, there's coefficient of variation, there's range, and the likes. And we're going to talk about some of these. So let's talk about range. With range, it's simply how far apart are the smallest and largest values in a particular variable, for a particular variable. So if the core 4 values that we see over here, if you sort them, all of these core 4 values, and after you sort them from smallest to largest and identify the smallest value and then identify the largest value, the distance between smallest and largest gives you the range. So how far apart is the smallest value from the largest value? That's a simple description of range. And it gives you more information about the variable that you're interested in and exploring and its characteristics. The other measure of dispersion is interquartile range. In order to calculate interquartile range, we first need to understand what quartiles mean. So the same way we think about median as the middle value in a set of values, in a range of values, quartiles show us the 25%. So the first quartile refers to after you've sorted from smallest to largest, refers to the bottom 25% of your values. The second quartile refers to the median, it's the halfway mark. And the third quartile refers to the top 25%. If I show you the visual that we skipped like 2 slides ago. This is what that means. So we already know what median is. It's the middle value in a range of values. First quartile, bottom 25%, third quartile, top 25%. If I know the first quartile value of a range of values, let's look at core 4 and see how we can interpret that. So if I know that the first quartile value for core 4 is 63, the way I would talk about this, the way I could interpret it is 25% of all students with core 4 scores have received a score in this unit below 63, and the remaining 75% of students have received a score of above 63. If I look at the median or the second quartile, which is 71, I could say that 50% of all students in this data set who have received a core 4 score have received a core 4 score of below 71, and the remaining 50% have received a core 4 score of higher than 71. If I look at the third quartile, which is 80 in this case, I could say that 25% of students in this data set have received a core 4 score of 80 or above, and the remaining 75% have received a core 4 score of below 80. Does that make sense? Questions? Nope. Online students, are we happy? Cool. Now, while I'm on this screen, I'll just talk about the mean as well. It simply says that on average, all the students in this data set on this list have scored 71.12 in core 4. And mode 63 says that the most frequently appearing score for core 4 is 63 among all students in this data set. Minimum is 37, so that's the lowest point a student has received, and maximum is 99. That's the highest one they've received. The minimum score and the maximum score, so the best performing student compared to the worst performing student in core 4 are 62 points apart in core 4. Cool. So what is interquartile range? Same way we talked about range being the distance between the maximum value out of all values and the minimum value out of all values. Interquartile range compares quartile 3 and quartile 1. So it's essentially looking at the middle 50% of all the values in your variable. If I look at core 4, IQR, or interquartile range, has been calculated as 17. So it's the difference between Q3, quartile 3, and Q1, quartile 1. 80 minus 63 gives us 17. This 17 essentially means that the middle 50% of core 4 values are 17 points apart. The reason we calculate IQR, we bother with IQR and don't always just focus on range, is that with range, you're looking at the minimum and maximum values. And sometimes in some variables, you get extreme values. There are instances where, I'll give you an example. With core 4, imagine a scenario where all the students in core 4, all the students in business analytics, receive a high distinction. Everyone gets above 80, except for one student. One student receives 0, right? That would be considered an extreme value when you compare with all the other values. If you have 500 students or 850 students, as we do, and out of 850, 849 students receive 80 or above, but one student receives 0, that one student can actually skew the data. It's an extreme value compared to all the other values, and it could mess up how you interpret that data, that variable. That's why we don't always just rely on range and we look at other stuff, including IQR. If anyone's wondering how we go about doing this, we'll see how that's done in this week's seminars. So coming up with those measurements, the mean, the mode, median, coefficient of skewness, IQR, Q1, Q3, all of that, how we do that in Excel, you will practice it in this week's seminars. All right, so let's talk about variance and standard deviation. Variance is probably the most challenging of the measures to talk about. We don't even attempt to interpret what it means. We do need to know how to calculate it, and we are going to use it in actually going from variance to standard deviation. So we usually calculate variance first, and we get standard deviation from variance, but we don't necessarily focus on trying to interpret variance. As the name suggests, it considers the variability of the values of a variable. The way we calculate, the way we think about variance is once you have considered your range of values for your variable and you calculate the mean, you can then start thinking about how far apart each value is from the mean, how distant each value is from your mean. So if you look at core 4, sorry. If you look at core 4, the mean has been calculated to be 71.12. Now, the first student has received 70. There is a distance between 70 and 71.12. So these two are 1.12 points apart. If you look at the second student who's received a core 4 score, they've got 63. This student's score is further apart from the mean compared to the first student. And you can continue looking at those distances for all the students in this data set. This gives you another interesting perspective or another interesting way of looking at your data and your variables, numeric variables, that is. To calculate variance, what we do is we measure all of the distances, we square them, and then we take the average. That's how it's done. You don't need to worry about trying to interpret variance. What we care about more is standard deviation. So this is the variance calculated here for this sample of data. From here, if you take the square root of variance, you get to standard deviation, which is 12.16 for core 4. That's what we care about, and that's what we try to interpret. So again, just an explanation, it's the square root of the average of the squared distances of every single data point, of every single value in your variable from your mean. So the distances from the mean get squared, you take the average of it, and you take the square root of this to get to standard deviation. The good thing about standard deviation is that it's of the same unit of measurement as your variable. So for instance, if the variable that you're considering is height, and you're measuring height in centimeters, your standard deviation is calculated in centimeters as well. If the variable that you're looking into is the unit of measurement is in cubic meters, standard deviation will be in cubic meters. If it's core 4, the standard deviation will be in the same unit of measurement as core 4. It essentially talks about how far apart the values, all the values are from the mean. So I'll give you, I'll repeat the example I gave you a little bit earlier. If all the students have received a core 4 score of 50 except for 2, the mean adds up to be 50. But you also see that they're not far apart from 50. It's just those two extreme values of 0 and 100 that are far apart. But the other case where half of the students have received 0 and half of the students have received 100, the mean is still going to be 50. But now the standard deviation is going to be a much larger value. And this tells us how spread the values of your variable are. Does that make sense? Any questions so far from students here or online? You can shout or use the microphone if you need to. I'll bring it over. Thank you.
I don't know, maybe I'm reading it weirdly, but the variance, do you just square root the mean and then you get the variance?
So with variance, you look at the distances between each value and the mean, then you square it, then you take the average. So I'll show you. This is the mean for core 4, right? And this is student number 1's core 4 value. The distance between these two is 1.12. If you square that 1.12 and then add it to the distance between 63, which is the second student's core 4 value, and 71.12. So 63 to 1.12, that's 8.12. Again, take 8.12, square it, add it to the previous squared value, and to the next one, and to the next one. Divided by the total number of values in this data set, in this variable, you get variance. If you then take the square of this variance value, you get standard deviation. Really appreciate you asking the question. Anything else? All good? Cool. The main point, don't worry too much about, so in this unit, we're not going to ask you to memorize how to do this stuff, right? It's not about memorizing the formulas and how to do it. It's mostly about understanding why you're doing things and knowing what the general steps are. With the specifics, you can refer to your notes, you can search online. All of this is available and you can have a look at them in your tutorial notes, in the lecture, in the class notes, et cetera, et cetera. But we do need to know why we're doing certain things. So the reason we are looking at something like standard deviation is because mean, mode, and median are not enough. They don't give you the full picture of the core 4 variable. So we look at other ways. It's like looking at something from different angles, and that will allow you to get a better understanding of what that thing actually is. That's the only way we can actually make better decisions when the time comes. Okay. So, standard deviation, hopefully that makes sense. A variable with a larger standard deviation. So if we're comparing core 1 values and core 4, and let's say core 4 has a standard deviation of 12 and core 1 has a standard deviation of 50, it means that core 1 values are a lot more spread out, if you like, compared to core 4 values, which have a smaller standard deviation value of 12. Those are more closely, those are closer together. The entire range of values are closer together. The next thing that we're going to look at is something called coefficient of variation. Very simply put, it's the exact same thing as standard deviation, but you're trying to bring it to the same unit of measurement as other variables. If you look at our Bic-versity data, we have something like core 4, and then we have something like attendance, right? Attendance and core 4 values are two completely different types of variable. Even though they're numeric, they're looking at different things. If you look at height, height is measured in centimeters. Core 4 scores is measured in points that you get for a particular unit. You should not be comparing these two, not their values and not their standard deviations. So if I ask you, we have the height of every single student in this data set, and we also have their core 4 scores. I've calculated their standard deviation values. The standard deviation of core 4 is 12. The standard deviation for height is 50. Which one is more spread out? You cannot answer this question. Just by knowing the standard deviation values, you cannot, because the standard deviation of height is measured in centimeters, whereas the standard deviation of core 4 is measured in points you get in a unit. So the only way you can compare those two standard deviations is if you bring them to the same unit of measurement. And that's what coefficient of variation does. It essentially simply takes standard deviation and divides it by the mean and gives you coefficient of variation. This will allow you to compare standard deviation values of different variables. I'm going to start talking about something called the empirical rule. we will come back to this in week 5 when we discuss probability, but it's a good idea to have a sense of this. What they've done, statisticians and people who do research, especially when it comes to numeric values, is they look at the distribution of values. What do I mean by distribution of values? If you look at core 4 scores, there's a few core 4 scores that fall below 50. If you look at all the range of values there. And there's a few that fall between 50 and 60, so a pass. And then there's a few that fall between 60 and 70, a credit. There's a few that fall between 70 and 80, a distinction, and a few that fall between 80 and 100, high distinction. If you count the number of core 4 scores that fall in each of those ranges, you can look at the distribution of core 4 values. I'll come back all these slides, but this is what I'm trying to refer to. So I have core 4 values, and I sort them, all of them, from smallest to largest. And then I decide on ranges of values that I'm interested in. And to me, all the fails will be grouped together. All the passes, 50 to 60, will be grouped together. All the credits will be grouped together, all the distinctions and high distinctions. And then I start counting how many appear in each of those groups, in each of those bands. Based on what I see, based on those numbers, I try to create a visualization, a graph. I'll call that graph a column chart. Each column represents one of those marks, a fail, a pass, a credit, a distinction, a high distinction. Now, each column is going to be either very tall or short or somewhere in the middle. The way I know which column should be short is based on the number, or tall or somewhere in the middle, is based on the number of students who fall in each of those ranges. So if I have 500 students and 499 of them fail, then I would have the tallest column for fails, and the other ones will be very short or non-existent. If I have 500 students, 100 of them fail, 100 of them pass, 100 of them credit, 100 of them blah, 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 then I will have 5 equally sized columns representing that distribution of values. Now, if I have no one failing, no one receiving no one receiving credit, distinction, or high distinction, and everyone receiving a pass, I will have a single column, very, very tall, 500 points tall, just for the pass column. Does that make sense? Yeah? So all of these figures, all of these different graphs gives me a visual representation of the distribution of core 4 values. What statisticians and researchers have looked at is how distribution of values in various variables look like. And they have found that in many, many cases, the distribution is usually going to look like this. So most of the values in a variable are going to be very close to the average. This mu, this right above 16, that symbol that you see, that represents the average. And the graph that you see, that distribution curve that you see, it represents the number of items that fall in each of the categories, in each of those columns, if you like. And it's going to be taller when more values fall in a particular range. In this case, they're showing that most of the values are very, very close to the mean. And as you go away from it, as you step away from the mean, whether it's to the right or to the left, the number of values that fall in those categories, in those bands, reduces, it comes down. The empirical rule that they've come up with essentially tells us that in many cases, variable distributions look like this. When you're very, very far away from the mean, you don't see a lot of occurrences. With our core 4, the mean is 71.12, right? A value very far away from 71 is 0. You're not going to see a lot of zeros when you look at all the core 4 values. Another value far away from 71 is 100. When you look at the distribution of all the core 4 values, you're not going to see a lot of 100s. Most of the values for core 4 are going to be close to 71.12. You don't need to know how this happens. You just need to know that they've discovered this. And it happens for pretty much everything. There's a lot of variables that follow this rule, whether it's in manufacturing, business, et cetera, et cetera. If we decide that a particular variable does follow this pattern of normalcy, there's a lot of interesting consequences to this realization. One of those consequences is that we can say 68% of all the values in that variable is going to be 1 standard deviation away from the mean. So if I believe my core 4 variable to follow this pattern, I can, without even doing any calculations, say very easily that 68% of all the core 4 values are going to be between 71.12 minus 12 and 71.12 plus 12. %68 of all the core 4 values is going to be between 58.97 and 83.28. Without doing any calculations, I can easily say that. As long as I'm sure that the distribution of core 4 follows that similar pattern of that curve. We'll explain how we can check whether or not our core 4 variable follows that pattern later on. I can also say that 95% of all the values fall between mean minus 2 standard deviations and mean plus 2 standard deviations. There are some implications to all of this, which we'll come back to in week 5. The last thing I'll say about this before moving on to talking a little bit about visualizations is that for every single value of a variable, let's say height, you can calculate something called the standardized score, Z-score, and that is how you can then compare the values of height with the values of core 4. If you don't, you cannot say a height of 1.70 meters is larger or smaller than a core 4 score of 78. It doesn't make sense to compare those two. One of them is in meters, the other one is in core 4 scores. But if you standardize them using this approach, then you can compare. All right, so far we've talked about a few measures of central tendency. We've talked about measures of dispersion. Those are all numbers, right? Statistics. We've looked at mean, mode, blah, blah, blah. The best business analysts, the top notch, those that get paid the highest bucks, those don't just report their findings in numbers. They also provide graphs, visuals, because decision makers, most of them can understand a graph a lot better than they can understand a bunch of values like mean, median, mode, et cetera, et cetera. And it's a terrific skill for us business analysts to have. And hopefully you'll get a lot of practice with this not just in your seminars, but through the assessment tasks that you'll be doing. So what do I mean by visualization? So we talked about mean, median, mode, quartile 1, quartile 3, et cetera, A box plot is a visual way that you can communicate those same values to someone. Through a simple box plot, you can let them know what your first quartile, third quartile, and median is. Those numbers still appear, but because it's a visual representation, some people can connect with it a little bit better. This is for a numeric one, right? Up to this point, besides mode, everything I've talked about refers to a numerical data, like core 4. You cannot do anything about a variable like origin, which has L and I in it. Besides mode, nothing can be done. You can't calculate standard deviation. You can't calculate any of those values for this variable. The only one you can calculate is mode. So what do we do about categorical values or variables? You essentially simply count them. So you look at something like origin, and you count the number of times L appears, domestic students, and you count the number of times I, or international, appears, and you compare those two. This is called frequency. So how many of your students are international versus how many of students are domestic? If you know the count, you can also calculate the percentages, which gives you proportions. So what proportion of all your students are domestic versus the proportion that are international? If you know those two values, you can visually also communicate your findings using something like a pie chart. The pie represents the whole thing, all of your students, the entire cohort. The bigger slice will represent the cohort that is more represented. So for instance, if you have more international students, the bigger slice will go to international and the smaller one will go to domestic. Another way to visually communicate categorical information is through columns. So if you're looking at the height of your students and you're looking at tall versus short, not the actual number, but tall versus short, you can have two columns, one for tall, one for short. Count the number of students who fall under the tall category, count the number of students who fall under the short one. And with the height of your columns, you can visually communicate which one is more represented in your sample update. With the histogram, which is a special form of column chart, we've already talked about how this is created. The histogram is specifically for numeric variables. So unlike the column chart that we just talked about, and we were looking at height, tall versus short being two columns, a histogram is actually used for a numeric variable. And the way they look at it is, like I said, they take numeric values like core 4 scores, and they count the number of core 4 scores that fall between 0 and 50, and the ones that fall between 50 and 60, 60 and 70, et cetera, et cetera. That count gives you these column heights, and then you can see the distribution. You will see in this week's seminar how we create a histogram and how we can go about interpreting it. There's one group of measures called measures of shape left. It's already 1:49. We don't have time to finish it, but I'll quickly go through it. Next week at the beginning of the class, I will come back to this and start here. Just letting you know that with measures of shape, we look at two items, skewness and kurtosis. Skewness essentially tells you, with that distribution that we were talking about, the curve that we were talking about in your histogram, if it's symmetric or if it's skewed one way or the other. Kurtosis looks at the peakedness or flatness. So how peaked it is or how flat it is. And again, this is something we'll come back to. The last thing that we didn't have time to look at are outliers. don't worry about this. Next week, at the beginning of the class, I will start from skewness, kurtosis, and then talk about outliers. In your seminars, you will practice looking at these. Thank you very much for joining me today. I hope this was fun. Let me know if you have any questions. Otherwise, take care, and I will see you again next week.